All right, video 11, part 11, and last number of functions, inverse functions. Till now, last number, maybe we upload some new numbers later on. We have this function x plus 1 plus 4 over x minus 1 defined on 3 plus infinity, and it's also a very important number. I think it will take like 2 videos to finish it. Part A. Part A, we have to do what? Prove that d y equal x plus 1 is an oblique asymptote. How to prove that d, which is x plus 1, it's like this one here, it's also x plus 1. How we prove it as oblique asymptote? All right, there's a rule we can use if limit of y of the curve minus y of a straight line as x tends to plus infinity, because we don't have minus infinity here, so it's only plus infinity. If it equals to 0, then it will be an oblique asymptote. So what is this limit? Limit y of the curve, it's x plus 1 plus 4 over x minus 1, right? As x approaches plus infinity. Minus y of d. d is x plus 1, so minus x plus 1 equals x plus 1 minus x plus 1, 0. What left is limit of 4 over x minus 1 as x tends to plus infinity. The answer is 4 over infinity, and 4 over infinity is what? Is 0. Then directly we can say y equal x plus 1 is an oblique asymptote. So first we have oblique asymptote. Don't forget, we will go back to it when we draw. This is very important. Part B. Part B, he says we have to prove that f admits an inverse function whose domain is to be determined. Okay. First, what is the domain of the function f? Again, domain of the function f is all set R except 1, because 1 makes x minus 1 0 and it is in the denominator, right? Union 1 plus infinity. If it is defined all the way from minus infinity to plus infinity except 1, this means f is defined and continuous over the part of the domain we need, which is closed at 3 plus infinity, because it is subset of the domain of f. Now we're good. We need to find the derivative f prime. Okay, f prime of x is equal, derivative of x is 1, derivative of 1 is 0, plus derivative of u over v. U prime, it's 0, v is x minus 1, minus v prime is minus 1 times 4 over x minus 1 square. Right? I'm doing this, the derivative of this part. It's u over v. The answer will be, have some more space. The answer will be 1 minus 4 over x minus 1 whole square. So it is x minus 1 square minus 4 over x minus 1 square. Factorize, it's x minus 1 minus 2 into x minus 1 plus 2. It's difference of two squares up here, over x minus 1 whole square. So it will be equal x minus 3 into x plus 1 over x minus 1 to the power 2. Okay? Now, I'm talking about 3 plus infinity. About this part is for sure positive value. All right? This part here, the least number it can get is 3x, right? Because from 3 to plus infinity is my domain. So this might be 0. And when it goes more than 3, so this value here will be positive, and this value here will be positive. So the whole thing will be positive or equal to 0. This means if the derivative is greater or equal to 0, then f is increasing, and f inverse of x, f inverse, right, of x exists. Now we have the existence of f inverse. Now what we do? Let's try to find the domain first, right? The domain. Okay. Let's try to find the domain. the domain of, okay, we have domain of f is from 3 to plus infinity, right? What is the limit of f of x as x tends to 3 plus, as x approaches 3 plus, right? Its limit of f of x, which is x plus 1 plus 4 over x minus 1 all square, right? As x approaches, x minus 1, not x minus 1 all square. It's x minus 1 only, I think so. 4 over x minus 1, yes. This is f of x. As x approaches 3 plus, if we put this x instead of 3 instead of x, we get what? We get 3 plus 1 plus 4 over 3 minus 1. This is 2. 4 over 2, it's 2 plus 4 is 6. So it goes to 6. Closed at 6 because it is by definition closed at 3. I think so. I did it open. It's not open. It's closed at 3. Yes. Okay. Back. As x tends to plus infinity, limit of f of x as x approaches plus infinity, it's plus infinity. It's x, so it goes directly to plus infinity. This part goes to 0 when we take it is equal. It tends to infinity. 4 over infinity 0. What left is x plus 1. 0, infinity plus 1 is infinity, so it's plus infinity. Then the domain of inverse goes from 6 plus infinity to 3 plus infinity. Okay? Now, let's find the points of intersection between the curve, which is y equal x plus 1 plus 4 over x minus 1 and y equal x, the first bisector. When we say y equal y, it goes like x plus 1 plus 4 over x minus 1 equal x. X minus with x, 0. So 4 over x minus 1 equal minus 1, right? Equal, this is minus 1. Equal minus 1 because 1 goes to the other side, minus 1. Okay? This one goes to the other side and there's 0, so it's minus 1. Cross product. Cross product minus x plus 1 equal 4. Then minus x equal 4 minus 1, it's 3. Then x equal minus 3. And minus 3 is a rejected value because it's out of my domain. My domain is 3 plus infinity. This means rejected value. This means no points of intersection. No points of intersection. Between what and what? Between the y equal x and the curve. Fine till now? This is important because I will talk again about the vertical tangent. What do you mean by vertical tangent? Okay. Okay. Here we don't have. Here I did something. We can directly say f of 3, by the way. The same. It will be equal to 6. I did limit because I thought that it is open interval at 3. It's not open interval. It's 3. So directly I can insert the point 3, right? And it's not 3 plus. It's a 3 because we have a point 3. So it will be 6 as well. No problem with that. Let's find the derivative at this end, point 3, right? Let's go back to the derivative. Let's go back to the derivative. Okay, if the derivative, if it is not required for you, you cannot use it. But I prefer to use it because it will make my drawing like more specific, right? What was the derivative? I found the derivative where we find it. I can't see. Come on. Derivative is this value. The derivative is here. Is x minus 3 into x plus 1 over x minus 1 square. The derivative is x minus 3 into x plus 1 over x minus 1 to the power 2. If we find the f prime at endpoint 3, we get what? 3 minus 3 into 3 plus 1 over 3 minus 1 square. I don't care for all. I care for this one is 0. It makes the numerator 0. This means it makes the whole thing 0. If the derivative at a point means the slope is 0, so we have horizontal tangent. We do have a horizontal tangent at point of abscissa 3 and of ordinate 6, as you can see. When we found f of 3, Here, the ordinate gives me 6.